In the previous session, we looked at the reduction formula for cos to the power of nx and for tan to the power of nx dx. Okay, so let's look at now some examples. So this is what we had arrived at as far as cos nx is concerned. So integral of cos nx dx is equal to 1 by n times cos to the power of n minus 1 x times sin x plus n minus 1 by n times the integral of cos to the power of n minus 2 x dx. And this we keep integrating, recursively applying reduction formula till the exponent on cos becomes either 1 or 0. Okay, so let's look at integral of cos to the power of 5x dx. Applying this formula, we get 1 by 5 times cos to the power of 4x times sin x plus n minus 1, that is 5 minus 1 by 5. So 4 by 5 times the integral of cos to the power of 5 minus 2, that is 3x dx. We have not reached 0 or 1 as the power of cos. So we again apply the same reduction formula. So 4 by 5 will be common. 1 by n, that is 1 by 3 times cos to the power of 3 minus 1, that is 2 times sin x plus n minus 1, that is 3 minus 1, 2 divided by n, that is 3 times the integral cos x dx. So here the exponent has become 1, 3 minus 2. This expression, let's open up the bracket. We get 1 by 5 cos to the power of 4x times sin x plus 4 by 15 cos square x sin x plus 4 2's 8 by 5 3's 15 times sin x plus c. So that is the integral of cos to the power of 5x dx. Now let's look at an even power. So integral of cos to the power of 6x dx is equal to 1 by n, that is 1 by 6 cos to the power of 5x times sin x plus 5 by 6 times the integral of cos to the power of 6 minus 2, that is 4x dx. Again applying the formula, we get 5 by 6 times 1 by 4 cos cube x sin x plus 3 by 4 times the integral cos square x dx. Now again we have a cos square x. So the power is still not 0 or 1. So which means we apply the reduction formula once more. Make sure that 5 by 6 is a common factor of everything inside the outer brackets. 3 by 4 will be a common factor for all the elements that are there inside the integral of cos square x dx. Now applying the formula, we get 1 by 2 cos x sin x plus 1 by 2 times the integral of cos to the power of 0 x dx. We have reached 0 now. Let's start simplifying it. As we keep simplifying it, we will end up with integral of cos to the power of 6x dx is equal to 1 by 6 cos to the power of 5x times sin x plus 5 by 24 cos cube x times sin x plus 5 times 3 times 1, that is 15 divided by 6 times 4 times 2, 6 4 is 24 times 48 cos x sin x plus 5 times 3, 15 times 1, so 15 divided by 6 times 4 times 2, 48 times the integral of 1 dx. And finally, that 1 dx integral is equal to x. And remember, we don't have to add plus c every time. In the final step, we can just add a constant of integration. Okay, so this was two examples, one with a odd power and one with a even power. Now let's look at some definite integral based on this. So we have integral of cos nx dx from 0 to pi by 2. So now here we are talking of in general. Now the definite integral formula, reduction formula is 1 by n cos to the power of n minus 1 x times sin x. Same thing that is there here. From 0 to pi by 2 plus n minus 1 by n times I sub n minus 2. So this would also be a definite integral from 0 to pi by 2. Okay, let's apply this. What do we get? Now here, the first term totally disappears. Why? Because cos pi by 2 is 0 and sine 0 is 0. So which means in both the limits, it will be 0. So it disappears. So we are left with only the second term. N minus 1 by n times the I sub n minus 2. I sub n minus 2 will be equal to n minus 3 by n minus 2 times I sub n minus 4. And I sub n minus 4 will be equal to n minus 5 by n minus 2 times I sub n minus 6. And this will keep on going till this numerator becomes 0 or the denominator becomes 0. Now combining all of this, we get I is equal to n minus 1 by n times n minus 3 by n minus 2 times n minus 5 by n minus 2 times dot 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 times k. So k will be the last term and k will be equal to pi by 2 if n is even and it will be 1 if n is odd. Now another problem, a very interesting one, let's solve that. Integral from 0 to a of x to the power of n dx by square root of a square minus x square. Okay, so we do a substitution. X is equal to a times cos theta. Differentiating it, we get dx is equal to minus a sine theta d theta. Okay, whenever we do substitution, we have to take care of the limits. So when x equal to 0, theta will be equal to pi by 2. And when x equal to a, theta will be equal to 0. Now carrying out the substitution, integral from pi by 2 to 0 of a to the power of n times cos to the power of n theta times dx, that is minus a sine theta d theta, divided by square root of a square minus a square times cos square theta. Let's bring minus outside the integral. We end up with integral from pi by 2 to 0 of a to the power of n times cos n theta divided by a square is common, so we take it out of the square root to get a times square root of 1 minus cos square theta times a sine theta d theta. Simplifying it, what do we get? First of all, we get rid of this minus sign by exchanging the limits. A and A gets cancelled and square root of sine square theta is sine theta. Sine theta gets cancelled. So we are left with a to the power of n times the integral 0 to pi by 2 of cos n theta d theta. And now we apply the pattern generated by this for the definite integral. We get a to the power of n times n minus 1 by n times n minus 3 by n minus 2 times n minus 5 by n minus 4. And we keep going till either the numerator or the denominator becomes less than or equal to 0. And then we tag k as one additional factor. And k will be equal to 1 when n is odd and pi by 2 when n is even. So for this definite integral, we can use this pattern. Now again, in our previous session, we had looked at integral of tan nx dx, which worked out to this. So let's again take examples with an odd power and an even power. Integral of tan to the power of 5x dx. This would be equal to tan to the power of 4x by 4 minus the integral tan cube x dx, which will be equal to, again we apply the reduction formula here. We get minus tan square x by 2 minus the integral of tan to the power of 3 minus 2, that is 1x dx. So we have reached 1. And we know the integral of tan x is minus natural log of absolute value of cos x. Now, you might be wondering, if it is minus natural log, minus times minus should become plus, but there is one more minus. So, minus. Now, let's look at tan to the power of 6x dx integral, which is equal to tan to the power of 5x by 5 minus integral of tan to the power of 4x dx. Again, tan to the power of 4. So, we apply the reduction formula again. So, minus tan cube x by 3 minus integral of tan square x dx. Still not 0 or 1 in the power. So, again, we apply the reduction formula. Now, here we are opening up the brackets here itself. So, we have minus tan cube x by 3. Minus times minus is plus tan to the power of 1x by 1 minus the integral of tan to the power of 0x dx. Simplifying that, we get tan to the power of 5x by 5 minus tan cube x by 3 plus tan x minus the integral of 1 dx. And integral of 1 dx is x. So this is the integral of tan to the power of 6x dx. Now, let's again look at definite integral. So we have integral from 0 to pi by 4 of tan to the power of nx dx. Applying this formula for the definite integral, we get tan to the power of n minus 1 x by n minus 1 from 0 to pi by 4 minus integral of tan to the power of n minus 2 x dx from 0 to pi by 4. Now let's apply the limits. We get tan to the power of n minus 1 of pi by 4 by n minus 1 minus tan to the power of n minus 1 of 0 by n minus 1 minus the integral 0 to pi by 4 of tan to the power of n minus 2 x dx. Now here tan 0 is 0. So this term disappears. Tan to the power of n minus 1 pi by 4, or if we just look at the tan pi by 4, we know it is 1. So anything to the power of 1 is 1. So 1 by n minus 1. This disappears, minus, as we keep repeating it, we get 1 by n minus 4 plus. So signs keep alternating. We keep repeating this till either the numerator or denominator. In this case, only the denominator becomes less than or equal to 0. And then we tag one additional k, where k is equal to x when n is even and k is equal to minus natural log of cos x when n is odd. Now let's look at integral from 0 to pi by 4 of tan 5x dx. So this becomes 1 by 5 minus 1 minus 1 by 5 minus 3. Next term itself we don't need to go for. Why? Because 5 minus 5 becomes 0. So we stop here itself. Minus last term would be minus natural log of cos x. So minus natural log of cos x from 0 to pi by 4. So 1 by 4 minus 1 by 2 is minus 1 by 4 minus natural log of cos pi by 4 minus natural log of cos 0. Simplifying this, we get minus 1 by 4 minus natural log of cos pi by 4 is 1 by root 2. Minus times minus plus natural log of cos 0 is 1. So natural log of 1. Now natural log of 1 is 0. So that disappears. And we are left with I sub n is equal to minus natural log of 1 by root 2 minus 1 by 4. Which is equal to, we can take the reciprocal and get rid of this minus. So we have finally natural log of root 2 minus 1 by 4. So that was the reduction formula method. Now, if you found this useful, don't forget to like, share, and subscribe. Questions and suggestions are always welcome. Thanks for watching. See you in the next session. That's it.